Hello everyone. Today we will discuss numerical integration. Okay. Basically, you know how to do integrate, right? For example, if I give you some integration like sin x dx, suppose this is from 0 to pi. Okay, so 0 to pi or so you can easily do this type of integration with it will be cos x, then you have to range from pi to 0. So cos pi is your minus 1 minus of 1. Basically we are taking the modulus of thing. If I say that what is the area, so you can say 2 unit. Now it is depend, is your function is integrable or not, right? For example, instead of this one, if I give sine of x square dx, obviously this function is bounded in between this range, so it have some value but we cannot integrate, right? So here we have to take the help of numerical integration. We cannot find the exact value, but some approximation solution we can find, right? So this is not possible analytically. So here we are taking the help of numerical integration. So there are several methods. Okay, so before going that, already in your last semester we have discussed the Riemann integration, right? So there partition, and in that partition you have find the upper sum, lower sum, this type of thing already discussed. That are analytical method, that your function is integrable or not, Riemann integrable or not, this type we are not going to there. But partition, for example, if I have some interval a to b, then you can divide this interval in several sub intervals. Okay, so suppose you are dividing by n interval, okay, so n equal interval, so each length you can say, if this length is h, so h equal to b minus a by n. This type of thing already discussed, and there you have observed this thing, that if you make your n larger, then your value will be more close to your exact result. Or you can say, if your step size you make more small, then your value will be more close to the exact one. Okay, so this type of thing already discussed. So basically here we discuss this thing. First we'll learn one method. That method is called Gauss Quadrature method. So basically you will see how many interval you are taking depending on n. Okay, so this method we use general, and here if you consider n equal to 1, then you will see that method is called trapezoidal method. And after that you have n equal to 2, if you do, then it is called Simpson 1/3 method. Okay, and after that you will learn one more method, that is called Newton Coates formula. So this is a little bit different. It is, you can relate with your Lagrange interpolation formula. There you have seen that Wx type. So this is that type. 1 minute, let me check what is in your syllabus. Yeah, so first we will cover this one. Okay, Newton's Coates formula. So this is different formula. Whenever you learn this thing, so basically from this formula also you can generate the formula for trapezoidal and Simpson one turn. Okay, so this type of thing again you can generate from here. Another thing, and whenever this type of thing, so basically it has a composite trapezoidal version also, but basically that are very easy. For example, if you have this interval a to b, so basically here you will break some interval. Okay, and in the each interval you use your that trapezoidal formula. Okay, so we will discuss there anyway. So from there you have composite trapezoidal, and here you have composite Simpson. Okay, so these are the overview of your this numerical integration part. Okay, and you know the error type of thing, right? That suppose you have, if you able to do the integration for some function, okay, so that value actually we denoted by exact value, or sometime with e notation. That exact value is your okay. So basically exact value is with suppose e, and the approximate value using your several method, whatever method you are using, that value we will denote by suppose I. Sometime for Simpson I will write is, some for trapezoidal will write it, that type of thing. So what is your error? So error, it is asked in your exam. So basically exact value minus the approx value, and obviously you can take the mod. Okay, so this is your error part. Okay, now we will start the discussion from the first one, that Gauss Quadrature formula. Okay, so suppose you have a length a to b. This is in general everywhere will use, and you have some function. Okay, so here basically this thing we are denoted with x0, and this is suppose your xn, right? So this is your x1, this is your x2, like that. Okay, and your, if this is your h, so h equal to b minus a by n. Okay, so you have to write it formally. You follow any book that you have a interval a v, you have divided with n sub interval, and with equal sub interval with each step length is here or h equal to b minus a by n, and you have to find the integration value a to b fx dx, right? So this is your fx function. Okay, so this is you have, and suppose let x0 equal to a, x1 equal to a plus h dot dot dot, xi equal to a plus ih, and xn equal to a plus nh, right? Where h equal to b minus a by n. Okay, again let suppose you are assuming that function value, let yi equal to f of xi. Okay, so basically you can say this value, this height is your y0, right? Corresponding this is your y1, the height, and this one, right? Like that. Okay. Okay, so this is your setup, and now what you have, basically your goal is to find a to b fx dx. So from here basically x0 to x0 plus nh fx dx. Now you are consider a substitution. Already you have used this substitution earlier, maybe in your Newton's forward backward formula, basically forward formula. Okay, so u equal to suppose x minus x0 by h. Okay, so this imply basically x equal to x0 plus uh. So if you do the differentiate, so you can have, u is a your variable, right? So h du. Okay, okay, so obviously here your whenever if you make that table x and your u, so if your x equal to x0, so then u value is your 0, and if your this value is your xn or b, so then your u value will be n, right? So what is this integration becomes, so you can write your I equal to h 0 to n f of, in terms of, so this is 0 n, and x will be become x0 plus uh, and this will be du, right? Okay, now you see we can write this thing with h on 0 to n. We can write this thing e of u f of x0. This is shift operator, right? That u times you are using that shift operator, so you are getting this. Okay, okay, now in the first chapter, not first, second chapter, you have learned that e is your 1 by delta, right? So if you use this thing 1 plus delta whole to the power u f of x0, you can write this is your y0 basically, du this form. Okay, now if you use the binomial formula here, so what you have here, 0 to n, so 1 plus u delta plus u into u minus 1 by 2 delta square plus u into u minus 1 into u minus 2 by 3 factorial into delta q plus so on into y0 du, right? Okay, Now if you break this thing, so first term you see 1 y0, so this will become h 0 to n. So here you have y0 plus u into delta y0, right? Plus u into u minus 1 by 2 delta square y0, plus you have this type of term. We are not going to, basically we are interested up to 2. Okay, so dot, 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 dot. Now if you do the integration, so what you will get, h outside, so no u, so u and the limit from n to 0, so n y0, right? Next integration of u will be u square by 2, right? And u square by 2 with the limit n and 0, so you will get n square by 2 into delta y0, right? Next you will get this is basically u square by 2, integration will be u cube by 6 minus u square by 2, right? So this is from n to 0, so overall you will get n cube by 6 minus n square by 2, right, into delta square y0. So in this way you are getting this formula. Okay, so this formula is known as your Gauss, basically sometimes it is called Gauss legendary quadrature formula. Okay, okay. Fine. Now here if you basically we directly not solve using this formula. After that question will be asked using your Simpson is very important. Okay, and your Newton course, this type you see your previous year question. So this is the overall theory for Gauss quadrature. Okay, Gauss legendary quadrature, this is from the SM Mulla book. Okay, anyway, now here if you put n equal to 1, okay, there are some n equal to 2. I told you that this is Simpson thing, and there are Weidel rule is not there. This is for n equal to 3. Anyway, so Weidel is not in your syllabus, so consider n equal to 1, so that is called the trapezoidal. So if you consider n equal to 1, so basically you have 2 points, y0 and y1, not more than that. Okay, so you have y0 equal to f of x0, that is your f of a, and you have 1 point y1, it is f of x1, or xn also you can say, this is your f of b. No more point, so there will be no role of your extra term. Okay, so your formula become I will be h into, you see, first one if you put n equal to 1, so this will be just y0, right? And then you have 1 by 2, and then you have delta of y0, that is basically y1 by y0, right? So this thing you can say this is your half into y0 plus y1, right? So basically half into h into y0 plus y1. Okay, so basically fa plus fb you can say. Okay, So what is this thing actually says? So suppose this is your a point, this is your b point, you have some function like that. Okay, I'm just taking some arbitrary function, and this is your suppose b. So you can say this height is your fa, this height is your fb. Okay, and this h is actually b minus a, because n is your 1, right? So this is y0 plus y1. So generally you know from the geometry this is nothing but this is a actually a, if you connect this, so it will become a trapezoid, right? And what is the area formula for trapezoid, this type of trapezoid? So that will be half of into h into y0, this one plus this one. Okay, I think this formula you know, right? You can think like what is this y0 plus y1 by 2? Basically it will be like someone here, right? So h times that one. So basically you can think this is what taking extra, and this is you have to subtract like that. Okay, basically the if you see this trapezoidal area, this is the trapezoidal, right? Instead of that, if you consider this one, these have same area, right? So here this height is basically y0 plus y1 by 2, this height. Okay, and this is, so overall you are getting this formula. You know the trapezoidal area formula also. Anyway, so what is this formula becomes? So a by 2 y0 plus y1, or in terms of f of a b you can write this is your f of a plus f of b. Okay, now we'll trying to estimate what are the error for this one. So we'll write this with it means a approximate value using trapezoidal rule. Okay, so what is the error? So we are writing et error in trapezoidal rule. Et will be a to b fx dx minus it. So basically x0 to x0 plus h f of x dx minus it. What you got? h by 2 into f of x0 plus f of x1. Okay, so this thing you have to find some bound of this thing. Okay, now obviously one thing is integration form, one is in some multiplicative product, so you have to make both similar type, right? So suppose your function is you have some function is, whenever it is integrable, so obviously your function will be there will be some function fx for which your if dash x equal to fx. Yeah, you may not know the exact form, but there will be some function that may be very difficult, but anyway there will be some function, right? So let there is a function fx such that f dash x equal to fx. Okay, so So if you substitute here this f dash x dx, so what you have, this is your fx, right? So fx, and you have x0 plus h and x0, so you are generally getting f of x0 plus h minus f of x0. Now if you break this thing using Taylor approximate formula, so it gives f of x0 plus h f dash x0 plus a square by 2 f double dash x0 plus so on. We may write one more term, h cube by 3 f triple dash x0 minus f of x0, right? So this cancel, so you have h f dash x0. So what is f dash x0? This is your f, right? So okay, in the next line we will write. So you are getting, this is your f of x0, because f dash x0 is your f of x0, right? So plus a square by 2 f double f dash x0 sorry, this is factorial. So on. So first term you have approximate, right? Now for the second term, if you do so what you have, so f of x1, that time you can write with f of x0 plus a, this thing. Again, if you break this term using Taylor formula, you have f of x0 plus h f dash x0 by h plus a square by 2 f double dash x0 so this is 2, right? Sorry. So you are getting h f of x0 plus a square by 2 f dash x0 plus h cube by 4 f double x0 plus h to the power 4 by, you can say, 6 times 2, that is 12 f triple dash x0, and so on, right? What you got earlier, you see, first term is same, right? This is same. Second term is your, this is also same. Third term, here there is some error. This is 1 by 4 and this is 1 by 6, right? So what is your error? Et will be, you see, 1 by 6 minus 1 by 4, right? HQ f double dash x0, neglecting higher order. So overall you are getting almost minus hq by this is 12. Okay, we are considering the negative sign. Okay, no issue. Or you can write this thing minus hq by 12 f double dash some xi, where xi lies between x0 less than xi less than x1. Okay, so overall whenever we are trying to find the bound, so we are taking the trying to find h is a fixed quantity, right? H no issue. Now you have some f, so we are trying to find its double derivative and find the maximum, what are the value possible. So from there we have an idea that what is your bound of your error. Okay, so in this way you have to do. Anyway, so this is your trapezoidal rule. Okay, next you have composite trapezoidal rule. So here your composite trapezoidal notation will be IT like trapezoidal, and there is some C for the composite one. So it is very easy. Suppose you have A to B fx dx. Okay, now basically this is Gauss Quadrature for n equal to 1. That is fine because we are taking the easiest case in your Gauss Quadrature formula. But suppose this is your A, this is your B. Okay, now suppose you have to do, already we have seen, right? And what is your normal trapezoidal? This is your this. But now in composite we will suppose divide in suppose 3 part. Okay, so this will be like this one. Here also you are considering one trapezoidal, this one, and this one. So you see, whenever you are using the normal trapezoidal, then the blue one, this is the area, right? Now in composite trapezoidal, here also you are using trapezoidal, but you are breaking in some sub interval. So you see here error is more less, right? This is in case of your composite one, this red one. Okay, anyway, so what you have to do, we are breaking in some sub interval. In sub interval. Okay, x0 equal to a less than x1 equal to a plus h, and xn will be a plus nh, right? So this integration become x0 to x0 plus nh, no issue. Now we can use the integration formula that a to b you can break with a to c plus c to a b, right? That thing here we will use. So this will write x0 to x1 f of x dx plus x1 to x2 f x dx plus xn minus 1 to xn fx dx. So for the first one, you know what you will get, h by 2 into f of x0 plus f of x1. For the second one, what you will get, right? I have not written, but yet I think this is clear, right? Now if you take common h by 2 this one, so you see f of x0 appear one time, okay, fx1 appear two times, right? fx2 appear two times. In this way it is going, and the last term will appear one time. I think this is clear. You just observe this term. Okay, or in terms of y0, if I say, so this will be y0 plus 2 into y1 plus y2 plus dot 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 yn minus 1 plus yn, right? So this is your formula for composite trapezoidal. So remember in this way that h by 2 times your first plus last, and plus 2 into sum of all the thing, right? So h by 2 sum of first and last ordinate plus 2 into sum of all other ordinate. Okay, so here if you trying to find the error, okay, so that error you can say et with c. So for each one you have one hq by 12, right? And if you take the xi will be your all the value in between a to xn, so each one you are getting hq by 12. So if you have n sub interval, so basically minus n hq by 12 f double dash xi, okay, where x0 less than xi less than xn, right? Now what is your h? h basically b minus a by n, right? If you use this formula, so you have b minus a by q by 12 n square f double dash chi. So this is the air formula. Geometrical interpretation already we have discussed, right, how it is working. So this is the overall formula. Okay, now coming to the point how to solve. Okay, so whenever you have given some function, so you know the this is your choice in how many interval you are using. Okay, sometime in the problem they will give. Okay, so let me consider one problem using suppose problem find 1 to 1.6 ln x using trapezoidal rule. Remember, normal trapezoidal we will not use, that are very basic, right? Basically we are, whenever they are referring trapezoidal, mainly composite trapezoidal. Trapezoidal rule in taking 6 sub interval. Okay, so your a value is your 1, b value is your 1.6. so what is your h value? B minus a by 6, so basically 0.1, right? So if you make a table, just normal table, you write 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, and in the using calculator you find the ln of all the value. Okay, so first one you can say ln 1 0, ln 1.1, this value is your 0.09531, 1.2 value is your 0.18232, 1.3 is your 0.26236, 1.4 is your 0.33647, 1.5 is your 0.40546, 1.6 value is your 0.4700. Okay, so basically they will give you how many decimal places you have to return, so accordingly you have to write that term. Okay, or maybe some significant figure also they can write. Correct up to here I am concerned 4. So whenever 4 decimal places they will tell, so you have to take 5 decimal places in your calculation, and finally you will approximate in your 4. So that type of thing already you know, right? Okay, so what will be the integration value? So that value is your ITC will be h by 2. H is your 0 point. You can write the formula once. H by 2 y0 plus, you can mark this, sorry, this is your xi, right? This is yi. Right, 1 2 3 4. It is your choice, accordingly you write. Okay, sorry, this is 0, right? Okay, so y0 plus y6 plus 2 times y1 plus dot 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 y5. Okay, then after that you will do the calculation, write all the term, okay, and find the answer. Okay, I think you will get, check yourself, 151692, so approximately 0.1517. okay, so this is your error, and if you able to find its exact value, okay, so ln x is integrable, right? You can find the exact value also, so from there you can find the what is the error. Okay, so your homework 1, find the value 0 to 1 dx by 1 plus x square, taking 5 sub interval no, not 5, 10 in sub interval, you can make this table, instead of vertical you can make it horizontal. It is your choice. Okay, no problem, because this is not taking time. Whenever you are making this table, maximum 3 to 4 minutes. Okay, taking 10 sub intervals and correct up to 4 decimal places. What is the error? Because you know this is integrable, right? The tan inverse x is the value, so this value is your pi by 4, so you can find the error also. Okay, using trapezoidal. Okay, I stop the class here. In your next class we will discuss the Simpson one-third and Newton codes, so then this chapter will be finished. Okay, before going to offline classes, I think we'll finish this chapter. Okay, bye for today.